Good morning, students. In your yesterday video, we had talked about projectile motion, but in that case, we had found out the equation of parabola from a height to ground. Okay, but in today's class, we are going to discuss the second condition, and that condition will be when an object is thrown upward and it will come back to the ground. Then it is called as ground to ground projection. Okay. For this you have to understand some basic logical graphical way so that you can get how we had figured out the equation of parabola. Okay. So first we are considering xy axis. And in this condition, I am throwing an object from ground and it is going upward direction and it is coming back to the ground level. Okay. So this is your x-axis and this is your y-axis. When I am throwing an object, that means the initial velocity is u. But in that case, I can say in this case, as we had discussed, the initial velocity is u. If you are considering horizontal motion, that means you always have to consider x-axis. If you are taking vertical motion, that means you have to consider y-axis. In this case, the initial velocity of the object is in the upward direction, but it is not exactly towards the x-axis or it is not totally towards the y-axis. Hence, I am just expecting, I am giving you this relation that if I am throwing this object with an angle of theta, so making this perpendicular and this will be your base, so you will have initial velocity with two components. Two components means if you are considering this vertical line is parallel to y-axis. So when you will consider vertical motion, then you have to consider this perpendicular relation. But when you are considering x-axis, then you have to consider your base angle with the theta. So the initial velocity is being divided into two parts. That it will be in the component of sin theta and cos theta. Clear? To find out this value, if I take that this is my initial velocity with respect to y-axis and this is my initial velocity with respect to x-axis, then what will be my condition? So I am taking it as sin theta is equals to, sin is equals to perpendicular upon hypotenuse. What is my perpendicular? Uy. That means initial velocity with respect to y-axis upon hypotenuse. Hypotenuse is u. Cross multiply your value, you will get u sin theta is equals to the value of uy. Same, I can consider cos theta. Cos theta is equals to base upon hypotenuse. That means it is ux upon u, which can be cross multiplied and you can get the value u cos theta is equals to ux. So here we have two components and that two components will going to decide the vertical and horizontal motion of the body. Now, as we had considered in the previous video, here also we are going to consider that same relation. First of all, the horizontal motion and then vertical motion, and so that you can very easily find out the relation. So first condition I am finding out for horizontal motion. For horizontal motion, that means a body which is moving with respect to x-axis. So everything will be considered with respect to x-axis. That means initial velocity ux will be taken as u cos theta. Displacement sx will be taken as x. Because the body is moving in a horizontal motion, hence the acceleration with respect to x-axis t. This is the second equation with respect to x-axis. So Sx is your x, ux is your u cos theta into t plus half into 0 into t. Hence this complete term will be 0. X is equals to u cos theta into t, where x upon u cos theta is equals to t. Hence we get the relation for the value of time t is equals to x upon u cos theta. Now the second part is your vertical motion. Now considering the vertical motion with the second half, vertical motion. Vertical motion means when a body is moving with respect to y-axis. In this y-axis, initial velocity will be taken as u sin theta. Second, displacement with respect to y-axis will be y, and acceleration due to gravity, because you are throwing an object towards upward direction. That means acceleration due to gravity will be minus g. Why it is taken as minus g? Because the body or an object is throwing opposite to the earth value. So it will be thrown upward. When it is thrown upward, that means acceleration due to gravity will be negative. Now again considering the second equation, Sy is equals to uy t plus half ay into t. Now substituting the values of t along with all these values, you will have y is equals to u sin theta into x upon u cos theta minus half g x upon u cos theta whole square. Okay, this is your relation. Now cancelling out your u and u, what you will have, y is equals to sin upon cos is equals to tan theta, and keeping this x in front of it, that means it can be written as x tan theta minus half g x square upon u square cos square theta. So we have, this is the second equation where a body is moving from ground to ground level, and in this case first the body moves upward, that is opposite to acceleration due to gravity, and then it is coming back to earth, that means it is coming towards the gravity. So hence it will have two better components, sin theta and cos theta, with respect to your initial velocity. So for this relation, for this ground to ground level, we have y is equals to x tan theta minus half gx square upon u square cos square theta. This is called as equation of parabola. This will be the relation for parabola, equation of parabola. Okay, so this is a very fine relation where you have to get ground to ground level, and in your next video we are going to consider the same relation with ground to ground level, but we are going to find out three basic terms related to projectile motion, which is very important, which usually comes in your numericals also, and even there